Hi students, this video is going to be talking about how solutes dissolve in a solvent and the concept of solubility and concentration. Okay, that's what the plan is. So I want to tell you that there are different conditions when you take a solute and you begin to put it into a solvent. Remember, the solute is what gets dissolved. The solvent is what does the dissolving. Together they make a solution. Solutions can be saturated, unsaturated, or supersaturated. A saturated solution is one that is holding all the solute it can, and no more solute can dissolve. Unsaturated means it could still hold more. If you were to add solute, more solute could dissolve. Supersaturated is a very specific situation where more solute than normally can be held in a solution is in it, except if you disturb it, it will fall out of solution or precipitate. And that's what you'll see in this initial picture here. You see the crystals in a supersaturated solution precipitating out. Now let's look at some solubility problems. Solubility curves, like this one, are the kind of thing that you use to understand how different substances are soluble and under what temperature situations they are soluble. So they tell much how much solute will dissolve, and specifically if you look at the y-axis, this is in a particular amount of water. In this case, it is 100 grams, 100 centimeters, or 100 milliliters of water that's listed on the y-axis. You need to pay attention to what that unit scale is as you do problems like this. So typically it's 100 grams of water, which is also equal to 100 milliliters of water. And then on the x-axis, it will show you the temperature in Celsius that that substance is soluble. Okay. Now understand that if you're looking at a point above the curve, on the curve, or below the curve, you would be looking at whether they were saturated, which is on the curve, below would be and above would be supersaturated. Okay. The best advice I can give you in doing these problems is to follow these steps, although there isn't a set formula. They're all a little different. So always go look for the curve, find the temperature, read the solubility, and then begin your thinking process. So let me demonstrate that for you here with this problem. Here's the problem. Will a solution formed from 110 grams of sodium nitrate and 100 milliliters of water at 30 degrees be unsaturated, saturated, or supersaturated? So following my own modeling, I find the curve, there we go, sodium nitrate. Read the temperature, go up to the curve, go across, and find the solubility. Or in this case, the point at which they're speaking of. And guess what? That point is above the curve, therefore it is supersaturated. This next one, we need to solve this problem. How many grams of potassium nitrate will dissolve in 100 grams of water at 45? Now remember, 100 grams of water is the same as 100 milliliters, which is the same as 100 centimeters cubed, the y-axis. Find the curve, there it is. Find the temperature that's listed. Read up and across, find the solubility that's listed. Write it down, 70, and then think. And then think about this problem. It says at 45, going up and across, 70 grams will dissolve. That's the answer they asked for. That's what we did. Next one. This one's a little bit harder. When you take a look at this one, it talks about 5 grams of water, not 100. So apply the same principle. Find the curve. Find the substance. Find the temperature you're talking about. Follow it across, read the solubility. Write that down and then think about how to solve it. This one, the answer is not 40. Read it again. What is the question asking me? In 5 grams of water. Oh, not 100. Okay. How do we go about solving that? Well, there's a couple different ways you can do it. But write down the solubility first, 40 grams of NaCl in 100 grams of water. And then you can use a picket fence, starting with the given that they gave you, which is the 5 grams of water, and using as a conversion factor